Welcome to an example in which we are using implicit differentiation to find dy dx for that equation. So now, what is implicit differentiation? Well, if you have an equation like if we got this y alone, um, and moved this to the other side, then we'd have minus x to the fourth minus 3, and then we'd have to fourth root both sides. And so then y would be alone. It's the fourth root of minus x to the fourth minus 3. That's kind of ugly. But anyway, that's explicit now. So explicit means direct, right? Straight up. So y is alone, explicit when y is alone. Okay. But it's implicit, write that, when you have x to the fourth plus y to the fourth equals minus 3. That's implicit because it's implied. Like if I say something, I go, um, you should study harder. It's implied that you might not be doing your best effort, right? You understand what I mean? I didn't directly say, I don't think you're giving your best effort. If I just said you should probably study harder, I'm implying something. I'm not saying it directly. That's what we're talking about here. Something's implicit if y is not automatically completely alone. Something's explicit if y is alone. Up to now, we've been doing derivatives where y is alone, explicit derivatives. But now we want to do implicit differentiation where y is not alone. Y not alone. So how do we do that? Well, we just start taking the derivative. So I'm going to go derivative of this side, derivative of that side. You can do the same thing to both sides. Okay, what happens on this side? Well, that's pretty easy, right? This. The 4 comes on down, subtract 1 from the power, 4x to the third, plus, and then right here, the 4 comes on down, subtract 1 from the power. But hold on, that's not all. Also times y prime. I know that probably seems totally weird. And what's the derivative of just a constant number? 0. So I did the derivative of both sides. Now you probably wonder, what the heck is that y prime? Why is it there? You didn't do that for x. Why'd you do it for y? Right. It's because y and x are not the same. I mean, I know normally in math and science up to this point in your math science career, you just thought letters are letters are letters are letters. X is x and y, whatever, whatever. Not quite so. X, x is the independent variable, and y is what we call the dependent variable, meaning it depends upon x. Right here, you can see if x happens to be 1, plug in x1 right there. What's that going to be? Negative 1 to the fourth, so negative 1 minus 3. Y will be the fourth root of negative 4 because that's imaginary. Anyway, my point is y depends upon x. If x takes on a certain value, then y depends on that and becomes a certain value, right? So y is the dependent variable. X is independent. You can put anything you want in for x, but y may or may not become anything. It depends on x. All right. Long story short, and it's probably already a long story. Why in the world is that y prime? Well, let me show you. Let me give you an example. I want to make sense of this for you before we go forward with this. What if, just think for a second, we did fourth power here, right? It's fourth power. What if I gave you sine of x, y equals sine of x to the fourth power? Do you know how to do the derivative of that? In fact, let me scoot it over a little bit. Let me prove to you. I don't want this just to be magic. I want to prove to you this is, you don't have to know this. If you want, you can skip the video at this point, but I want to prove it to you. So y prime, the derivative, how would you take the derivative of this? Before it comes down, the sine x stays the same, subtract 1 from the power. But that's not all. I hope you know. I hope you know that's not all. Why not? Because the inside is not a simple x, right? The inside is not a simple x. It's a sine of x. So what does that mean? Let me pick that up. You got to do the chain rule. You remember that? So in fact, I'll do it right here. Get that to erase. There we go. You got to do the chain rule. The chain rule, the derivative of sine x. And what's the derivative of sine x? Cosine x. That's the real derivative, right? Remember the chain rule. If the inside function is not a simple x, you do the outside first, bring down the 4, subtract 1, and then you multiply. Since the inside was not a simple x, it was sine x, you multiply by the derivative of the inside, cosine x. Well, that's what I'm doing here. Do you see that? Um, when when I've got y, here, let me bring it down here. When I've got y to the fourth power, y is like sine x. It's like sine x to the fourth power. How do you take the derivative? The 4 comes down, subtract 1 from the power, but y, the inside there, is not a simple x. Clearly, it's a y. So that's y prime. The chain rule tells me I have to take the derivative of that inside function, just like I would for sine x or anything else that's a function of x and not a simple x. Remember, y is a function of x. Okay, that's you always got to remember y is a function of x. All right, so how do you finish the problem? Well, they want us to do y dx. That's the same as y prime. How to do that? I'm just going to grab this 4x cubed, jump it to the side. Really, I'm subtracting 4x cubed from both sides, but just trying to save some time in my process. So then we get 4y cubed times y prime equals minus 4x cubed. And last step, to get y prime alone, right? We're trying to find y prime. What do we got to do? Divide by 4 y to the third. What do you do to one side? Do to the other. Boom. Y primes alone. These 4's cancel, actually. It's minus x cubed over y cubed. I don't know why in the answer they kept the 4's, but it's good either way. And so there we go. So the key to implicit differentiation is to remember that y and x are not the same. Y is a function of x. It's not a simple x, kind of like sine x or cosine x or whatever, 10x squared plus 3x, whatever. We don't know what it is, but it's some kind of function of x. It's a dependent variable. So when you do this kind of thing, you do for x, it doesn't matter. Just bring down the 4, back to power 4x cubed. No big, because the inside is just a simple x, so we don't need to do the chain rule. But for y, bring down the 4, subtract 1, and then you got a chain rule tells you you've got to multiply right there. That was the chain rule by the derivative of the inside because it's not a simple x. And so there we go.